Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq bin Zainal, ID 531061150009. I'm from University Kuala Lumpur, Malaysian Institute of Aviation Technology, Class 1AM1. Today, I would like to teach Physics and Aerodynamics on the topic Optic and Sound. Definition of optic. Optic is the branch of physics which involves the behavior and properties of light, including its interaction with matter and the construction of instruments that use or detect it. Dispersion of light by prism. These colors are often observed as light pass through a triangular prism. Upon passage through the prism, the white light is separated into its component color: red, orange, yellow, green, blue, and violet. The separation of visible light into its different color is known as dispersion. Electromagnetic spectrum. The electromagnetic spectrum is the range of all possible frequencies of electromagnetic radiation. The electromagnetic spectrum of an object has a different meaning and is instead the characteristic distribution of electromagnetic radiation emitted or observed by that particular object. Law of reflection. In the diagram, the ray of light approaching the mirror is known as the incident ray. The ray of light that leaves the mirror is known as the reflection ray. At the point of incidence where the ray strikes the mirror, a line can be drawn perpendicular to the surface of the mirror. This line is known as a normal line. Color combination. This demonstration with the color box illustrates that red light and green light add together to produce a yellow light. Red light and blue light add together to produce magenta light. Green light and blue light add together to produce cyan light. And finally, red light and green light and blue light add together to produce white light. This is sometimes demonstrated by following color equation and graphic. Okay, now reflection. In the diagram at left, a light ray PO strikes a vertical mirror at point O, and the reflected ray is OQ. By projecting an imaginary light through point O perpendicular to the mirror, known as the normal, we can measure the angle of incidence theta I and the angle of reflection theta R. The law of reflection states that theta I equal theta R, or in words, the angle of incidence equal the angle of reflection. Convex mirror. The image in the diagram above is a virtual image. Light does not actually pass through the image location. It only appears to observe as though all the reflected light from each part of the object is diverging from this virtual image location. The fact that all the reflected light from the object appear to diverge from this location is supposed to mean that any observer would view a replica or reproduction when sightseeing along a line at this location. So now is concave mirror. A concave mirror is a mirror that is curved inward the middle. This might help you to remember this if you think that when you look in a concave mirror, it looks like you are looking into a cave. The law of reflection is still true for a concave mirror, but because the mirror surface is curved, the angle at which light hits the surface, also known as the incident angle, is different depending on which part of the mirror the light hit. This causes concave mirror to be able to focus light similar to the way that a lens in a camera focuses light and form an image. Unlike a flat mirror, concave mirror can form a real image that are projected out in front of the mirror at the place where the light focus. Here this is a reflection, so you can see the diagram. Light refraction index. The refraction index determines how much light is bent or refract when entering a material. This is the historically first use of refractive indices and is described by Snell's law of refraction. Index of refraction of water. A stick immersed in water will appear to be bent below the water level. This is due to the fact that the incident ray from every point below the water level bend away from the normal. When they reach the observed ice, the ice visualizes the object by retracing the refracted ray as straight line. Hence, every portion of stick below the water appear to be a higher level, and thus the stick appear to be bent below the water surface. The next are refraction of air. The index of refraction of vacuum is considered to be bench reference as NS1. The index of refraction of air is close to the of vacuum and it is approximately 1.0003. However, the index of refraction of air becomes lesser and lesser as the air temperature becomes warmer and warmer. In a hot climate, the air gets so warm to the extent that the index of refraction becomes so low that the rays from the sky are refracted instead of refraction. This phenomenon is called total internal refraction. Refraction of glass. The index of refraction of glass is very important information because we use glass material in many situations in real life. The most commonly used type of glass are chrome glass and flake glass. The indices of refraction of glasses are 1.52 for chrome and 1.62 for flake glass approximately. The index of refraction of glass has a great application in a right prism, which are used as reflector by total internal reflection process. Negative index of refraction. Some material with negative permittivity and negative permeability found to have negative index of refraction. When light ray enter the medium of this material, the reflected ray bend in such a way that they cross even the normal and the rays are sent back to the same direction in a different medium though. This type of refraction is called negative refraction. Type of lens. There are two types of lens. First one is convex lens and second one is concave lens. This is formula for lens. Since this formula may be used for both convex and concave lens involving both real and virtual image, a sign rule, positive or negative, must be applied. Okay, next topic is wave motion and sound. Okay, so you can see the diagram of wave motion. Mechanical wave. Mechanical wave are waves which propagate through a material medium, solid, liquid or gas, at a wave speed which depend on the elastic and inertial properties of that medium. There are two basic of wave motion for mechanical wave: longitudinal wave and transverse wave. Okay, so you can see the transverse wave. This is the direction of energy wave. Transverse wave. A transverse wave is a moving wave that consists the oscillation occurring perpendicular to the direction of energy. If a transverse wave is moving in the position X direction, its oscillation are in up and down direction that lie in the Y to Z plane. A like example is transverse wave. With regard to transverse wave in matter, the displacement of medium is perpendicular to the direction of propagation of the wave. A ripple in pond and a wave on a string are easily visualized as transverse wave. Longitudinal wave. A longitudinal wave, also known as I wave, are wave in which displacement of medium is in the same direction as or the opposite direction to the direction of travel of the wave. Wave characteristic. Waves are disturbances that travel through a fluid medium. Several common wave characteristics include first, frequency, second, velocity, third, wavelength, fourth, amplitude. Characteristic of wave. Wavelength, the distance between two crests. Frequency, the number of wave crests that pass a point every second. If one crest goes by every second, then we say that the frequency is 1 cycle per second or 1 Hz. Amplitude, the height of wave crest above the undisturbed. Velocity, the speed and direction that the wave crest itself is moving. Interference and standing wave. Interference and standing wave. There are two types of common interference. First one, constructive interference, and second, destructive interference. Standing wave. Standing wave or stationary wave occur in wires that are tightly stretched between 2 points. If this wire and plug are all caused to vibrate, transverse wave travel to the end and are reflected back. As the wave cross each other in their travel backward and forward along the wire, a stationary or standing wave pattern is formed. Sound. Definition of sound: vibrations that travel through the air or another medium and can be heard when they reach a person's or animal's ear. Sound produced by continuous or regular vibration, as opposed to noise. Frequency: F equal to 1 per T, whereas T in a second, unit of hertz. The higher the sound, the higher the pitch. Sound of propagation: transmission and reception of sound. There are three: medium, source, and detector. Doppler effect: the apparent rise in the pitch or frequency of a sound as its source approaches nearer and decrease in pitch as the source moves away. This formula for Doppler effect map. Speed of sound: the speed at which mechanical vibration of sound travel in an elastic medium. Second, varies with temperature and altitude. So you can see the three diagram. The Mach number: the ratio of the speed of the airplanes to the speed of sound in the same atmospheric condition. Mach number equal to speed of the aircraft divided by speed of sound. Resonance: the natural frequency of a given object vibrates naturally or without the external force. Two objects have similar frequency. If one vibrates, the other can move too. And lastly, destructive force. I think that's all from me. I hope all of you enjoy my video, and thank you.